Okay, all of you are able to see the form. We have come up to this one. We have completed up to this question. Now next question is, the argument has a true conclusion. Identify the argument as which is as valid or invalid. Okay, it has a true conclusion. We have to identify it. Is it a valid or invalid? What are the propositions are? Rational numbers are real numbers. Integers are rational numbers. Okay. Conclusion is integers are real numbers. Okay. Is it valid or not? You have to put it down. Okay. Using rules of inference, you can do this. Just take out your pen and paper. Yes. Rational numbers are real numbers and integers are rational numbers. Okay. What the conclusion is? Integers are real numbers. The conclusion is true. So is it valid or invalid?
Valid.
How? Yes, tell me your logic. Who told this one it is valid or yes? Yes, what is the logic behind this? Actually, it's very simple. And this question is something confusing. When in the first sentence, it's already declared that argument has a true conclusion. When the conclusion is true, that argument is valid, that we already know. Whatever the propositions are there, the already told fact is that argument has a true conclusion. So always that argument is valid. Okay. So the option 1 is correct in that case. Getting? Now you tell me this one. Decide whether the statement is true or false.
False.
How do you know that? Yes. Intersection is what?
Common element.
Common elements. Are there any common elements in the empty set and the set given 10, 11, 2? No. Means intersection of that will also be the empty set. Yes. So the given statement is false. Use the truth table to decide if the statements are equivalent. Yes, two statements are there. Use the truth table. Q and negation P. And the second is negation P implies negation Q. Whether they are equivalent or not. Draw the truth table. I am also doing same. All of you do this. This is for your practice.
Not equivalent.
Not equivalent.
Yes, ma'am.
Okay, means second equation is, oh, sorry, second option is correct one. Okay. All of you are doing this or not? They are exactly opposite, I think. Yes or no?
Yes, ma'am.
Columns coming here are FFTF and TTFT. Is it correct?
Yes, ma'am.
So the two given statements are not equivalent. So second option will be there. Next is state true or false. What is there? X is a counting number greater than 32. Tell me about this. Is
False.
it true? It is a
False.
false because counting number greater than 32 starts from 33, not from 32. Okay. Clearly mentioned that it is greater than 32. If it is equal, means it is said that X is greater than or equal to 32, then it will start from 32. Okay. So this statement is also false statement. Second option is the answer here. Next question is find the number of subsets of a set X such that X is an even number between 17 and 37.
1024.
1024.
24.
Yes. How did you do this?
Even number between even number 80 to 36 2 raised to 10.
18 to 36. Okay. What the number comes there? 18 to 36.
10.
18, 20, 22, 24, 26, 28, 20, sorry, 30, 32, 34, and 36. 10 numbers are there. So how many subsets will be there? 2 raised to 10, that is 1024. Okay. Last option is the answer for this question. Next question is determine if the argument is valid. P is if a number is even, then it is divisible by 2. Q is if a number is divisible by 8, then it is divisible by 2. R is some numbers are either even or divisible by 8. Okay, and the conclusion is some numbers are divisible by 2. Okay, so solve this. You are going to solve this. Whether the state argument is valid or not, you are going to tell me. We have solved in the class that example of I think it is sunny, then we'll go to swim, otherwise we'll go to some other place and we'll come back at home till the evening. Like that, we have taken the example. This is another example in the same type. Okay. Draw the same chart that was in that slide. Take your suppose time of 2 or 3 minutes. You can do that. All of you are doing this. Yes, tell me whether the argument is valid or invalid. Yes, what is the answer?
Invalid.
Invalid. Yes, it is invalid. How did you solve? Mihir, can you tell us? Tell us or your friends. I know that it is invalid.
Hello, ma'am. I solved in logically sequence.
Logic, sorry, I didn't
Logically.
hear. Logically?
I solved logically, not in pen
Yes,
or
on,
paper.
okay, on paper. Anybody has solved on paper? For solving on paper, you can change names of propositions. No any issue in that. Means you can take a number is even, then it is divisible by 2. A number is divisible by 8, then it is divisible by 2. And third one is some numbers are either even or divisible by 8. This R is not the correct one. Here it gets the uh, confusion there. Okay. And lastly, the conclusion is some numbers are divisible by 2. In rules of inference, what we do? Yes. In rules of inference, what we do? Here, how we will take is, suppose we will take the prepositions like small a is, number is even, okay, b is, it's divisible by 2, then c is, number is divisible by 8, c is divisible by 8, and what are here is some numbers are either even or divisible by 8. So what p becomes here is, if a number is even, then it is divisible by 2. Okay, what I have done, I'll tell you again. A is, suppose the number is even, B's meaning is the number is divisible by 2, and C's meaning is the number is divisible by 8. Okay, now I will means how the P preposition is prepared here, that I will prepare in our statements like A, B, C. What it is here, if a number is even means what we have is A, okay, then it is divisible by 2. Okay, A implies B. Okay, if a number is even, then it is divisible by 2. Okay, so P implies what? A implies B. P meaning is A implies B. Now what Q meaning is, if a number is divisible by 8, then it is divisible by 2. Means number divisible by 8 is C, and C implies B, that if a number is divisible by 8, then it is divisible by 2 also. So what Q is, C implies B. And what R is, some numbers are either even, okay, or divisible by 8. Means A or C. Okay, so we have 3 statements: A implies B, C implies B, and A or C. What we have to do in these cases, we have to either we can go for truth table, or we can go for those rules of inference. Okay, and ending of all these, if we go for what we can say, if we go for rules of inference, then what we have to do is, if ending of, we have to do all these things, P, Q, and R. That our meaning is A implies B, C implies B, and A or C. And then we have to implies that ending with our conclusion. Some numbers are divisible by 2. Means what? B. All these things, P and Q and R implies B, that we have to do. Okay, and if that comes true, then this statement is valid. Okay, if it doesn't come, then it is invalid. It is the truth table method. But what the rules of inference method is? Yes, we directly have to uh, use the rules which are given in the slides. Also, we have given, and which are existing rules are there. Using those rules, we have to go for these one. Okay, and here it doesn't come true, the conclusion, so it is invalid. Okay, for the sake of what we can say, um, surety or assurity, we can go for truth table method, whether it is correct or not, to see that. Okay, but here it comes as invalid. The second option is correct in this case. Okay, I hope you are get the simplified version of that question. Okay, in such type of questions in exam, suppose it comes, just simplify those questions in your language, in your own propositions, and then go for whichever the method you feel that it is okay. Okay, you will go for that, and then you will find it is valid or not. Okay, and the last question from this is, here it is, decide whether the argument is valid or not. If I am hungry, then I will eat. And Q is, I am not hungry. And the conclusion is, I will not eat. Okay,
Valid.
it is a valid one. It's not that complicated as the earlier was. It is a valid one. Okay, such type of questions are there in your exams. If I get more, I will provide you. Otherwise, you will have to practice by yourself. Okay, and again I am telling, if you go for your study in theory for the perfection, you will surely can give the MCQs correctly. Okay, whatever the minute things are there that you will see, those can be considered in the MCQs. Means uh, little things they uh, think when they come up with the MCQs, means examiners. Okay, so we are keeping that in mind. You have to go for first theory questions. Okay, so this form gets complete. We will go for next MCQs link that I provided you. Are you able to see? It was on relations and functions. Okay, we'll see one by one. What type of relation is R? Okay, what type of relation is R? 1 3 4 2 2 4 2 3 3 1 on the set A equals to 1 2 3 4. Answers I have already made it bold, but logically also we are going to solve this. How it is like that? Yes, answer is none of this, but how does it come? For reflexive relation to be reflexive, what type of element should be there in the relation set? Tell me. For reflection to be reflexive, what type of element should be there in the
1, 1, 2, 2. Like that.
1, 1, 2, 2, 3, 3, 4, 4, like that. Okay. Then for transitive, how would it be? Is there, okay, means for A to B, B to C, A to C should be there. But for all the items, it is not there. 1 to 3 is there, 3 to 1 is there, but 1, 1 is not there. Then again, 4 to 2, 2 to 4 is there, but 4 to 4 is not there. 2 to 3, 3 to 1 is there, but 2 to 1 is not there. Okay, so transitive type of relation also it is not. What about symmetric? For 1, 3, 3, 1 is there. For relation to be symmetric, what is needed? For 1, 3, 3, 1 is there. 4, 2, 2, 4 is there. But what about 2, 3? 3, 2 is not there. So this relation is not symmetric also. So what the option remains is none of these. Okay. So answer of this question is none of these. Then the second one is if A, B, C are three sets such that A intersection B equals to A intersection C and A union B equals to A union C, then what is there? A equals to B, A equals to C, B equals to C, or A intersection B equals to D. What is there?
B equal to C.
B equal to C will be there because A is common there. So by left cancellation law, what we get is B equals to C. Then the third question is if function f is from R to R, G is also from R to R, and H is also from R to R. R to R means what? Real number set, okay? Such that f of x equal to x square, g of x equal to tan x, and h of x equal to log x. Then the value of h composite g composite f of x, what it is? If x equal to root pi by 2, if x equal to root pi by 2. Now, how the composition of relations will go? First, what we have to evaluate in this case? Yes,
G of f of x.
g of f of x. Okay, means what? First, we have to evaluate is tan x square. Okay, tan x square means what again? Tan root pi by 2 square. And root pi by 2 square means again pi by 2. So tan pi by 2. G of f of x will be tan pi by 2. What the value of tan pi by 2 is?
Infinity.
Tan pi by 2 is infinity. Take out your calculus. What is the value of tan pi by 2?
Infinity, ma'am.
Yes, ma'am. Infinity.
Okay. Then what the next step will be?
Log of infinity not define it.
Again, it will be What will be what is the value of tan? What is the value of tan pi? I think it is 1 or so.
Tan pi 0.
Tan pi 0. Okay. Okay.
Ma'am, x equal to under root of pi by 4 पाहिजे ना 0 येण्यासाठी.
Yes.
X equal to under root of pi by 4.
Yes,
Zero.
yes. But root pi by 2. Okay. Pi by 4. Yes, yes. It will come as means tan of pi by 4 is 1. Am I
Log of
correct?
0.
Tan pi by 4 is 1, na?
Yes, ma'am.
Then first what we did for others, see here, first we took it like g of f of x, okay? Means what we performed here is tan of x square, okay? Tan of x square, x is root pi by 2, okay? Means root is for pi only and divided by 2 there. So what it came like tan pi by 4, okay? X square, now we have to evaluate for x square, means root pi by 2, its square is pi by 4. So for in g of f of x, what we have to evaluate is tan of pi by 4 and it is 1, okay? Then h of g of f of x means what again? Log of 1 we have to perform and log of 1 it is 0, okay? So answer is 0 here. Getting this question? Then next is fourth question. It is if f is a real function from R to R and G is function from R to R defined by f of x equal to 2x plus 3 and g of x equal to x square plus 7, then the value of x for which f of g of x is 25. Yes. How you will go for that is g of x is x square plus 7, okay? How you will go for that now is we have f of g of x means we have to perform the operation like 2x plus 3 bracket square plus 7, okay? 2x plus 3 bracket square plus 7 is equal to 25. We have the equation like this: 2x plus 3 bracket square plus 7 equal to 25. Tell me the value of x now.
Plus minus 2.
Plus or minus 2. Yes. How does it become? 2x square plus 14 plus 3 equal to 25. Okay. Then 2x square plus 17 equal to 25, 2x square equal to 8 and x equal to 2. Okay. So what we have it like value of x is plus or minus 2. Okay. Shall we go for the next question? See here what the question is. Next one. Let f of x equal to x minus 1 upon x plus 1. Then f of x is, then f of x is. What we will do here is, in composition, at the value of x, what we will write is x minus 1 upon x plus 1. Okay, means f of x equal to x minus 1 upon x plus 1 minus 1 upon x minus 1 upon x plus 1 plus 1. Okay, like this it will be.
minus
Evaluate
1
that one. Evaluate that one. What the value comes?
minus 1 by x.
Yes, it comes as minus 1 by x. All of you are doing this or not? Then we'll come for sixth question. What it is? If a binary operation star is defined on the set Q plus of all positive rational numbers by A star B is equal to AB by 4, then 3 star 1 by 5 star 1 by 2 is equal to
3 by 160.
3 by 160. Have you calculated all these things here?
Yes, ma'am.
It comes as 3 by 160. First, what you will do is 1 by 5 into 1 by 2 divided by 4. That you will be calculating first, and whatever the answer comes there,
1 by
again,
4.
yes, 1 by 40. And again, what we will do for that is performing the same operation with 3 on that result.
40.
AB by 4, AB by 4. How it will be? 3 into 1 by 40 divided by 4.
4.
So what it comes like 3 by 160. Okay, it is the answer for this question. Then seventh one is, let star be a binary operation on set Q of rational numbers defined as A star B is equal to AB by 5. Write the identity for 3 star 5.
3. 3.
The identity comes as 3. Okay, here it is logically also correct one, as 3 is the identity element. Then the next question is, for binary operation star defined on R minus 1 such that A star B is equal to A by B plus 1 is. How do we go for that is, for binary operation star defined on R minus 1. R is what? R is real number sets. Okay, means 1, 2, 3, 4 like that. And from that R, 1 is excluded. Okay, 1 is excluded, means the set starts from 2, 3, 4, 5. R minus 1 is given. Getting the meaning of this? R minus 1. Here 1 is not there in this set. So what we have to do is, considering this set from 2, 3, 4 and 2, 3, 4, like that, all those numbers will be there. How it is defined is A star B is equal to A by B plus 1. Okay, means the whole term is A by B and plus 1. So what type of equation it is, sorry, operation it is, that you have to see whether it is associative or commutative or something like that. How you will go for that? Yes. Here for A by B, the operation is division. A is divided by B. Okay. And the division operation is not commutative also, associative also. Means A by B is different from B by A unless and until A is equal to B. Okay. So A by B or B by A, it is going to differ the what we can say, means order is important in division also and in subtraction also. So what we can take it like, it is not associative also and not commutative also. So what the answer here is both A and B. Okay. So what's the next question is, if the function f is from R to R defined by f of x equal to 3 minus 4x, what type of function it is? Yes. 3 minus 4x is the function of x. What type of function it is? Yes, who will tell me? It's a type of one-to-one function, because for every one value of x, there will be unique value of f of x. So it will be one-to-one function. Getting? Then the next question is, given set A equal to 1 to 3 and the relation R is 1 to 2, 1, then the relation R will be reflexive if 1, 1 is added, symmetric if 2, 3 is added, transitive if 1, 1 is added, and symmetric if 3, 2 is added. What is correct one? Will it be reflexive only if 1, 1 is added? No,
No,
to be
ma'am.
reflexive, we have to add 1, 1, 2, 2, and 3, 3, all the things. Will it be symmetric if 2, 3 is added?
No, ma'am.
No, because 2, 3 is added, 3, 2 is not there. Symmetric if 3, 2 is added? No, it's not the case. And the correct one is transitive if 1, 1 is added. How it is? Transitive means what? A to B, B to C, then A to C should be there. Means 1 to 2 is there, 2 to 1 is there, means 1 to 1 also should be there. So it becomes his transitive. So the third option is the correct option. Then the next question is 11th one. If n of a cross b is equal to 6 and a is 1, 3, then what is n of b?
3.
3, because cardinality of cross product is multiplication of single set cardinalities. A cardinality is 2 and cross product cardinality is 6. So 2 3s are 6. So cardinality of B will be 3. Okay. Now the next question. It is A equal to ABP, B equal to 2 3, C equals to PQRS. Then N of A union C cross B, what it will be?
12.
A union C. What is A union C?
4.
ABP,
6.
ABPQRS is A union C and B is 2. So 6 into 2 is 12. Okay. Take the next question. The range of relation R equals to X and X square. X is a prime number less than 13. So what the range of that set will be? Range means what? Yes. Elements from second set. Okay. If suppose X is equal to prime number less than 13, 2, 3, 5, 7, 11. Okay. And in the second set, their squares are there. So the third option will be correct. 4, 9, 25, 49, 121, like that. Okay. Then the next question is, if A 8 and 6B, okay, A8, 6B represents an identity function, then the value of A and B are respectively. Yes, identity function means what? In types of functions, we have seen identity functions. See the slides and then you will get that concept. Identity functions are there. In that case, the values are same like as given in the relation. So values of A and B are respectively 8 and 6. Okay. Then we'll go for next question, that is 15th one. Let F and G be two functions given by F equal to 0, 1, 2, 0, 3, minus 4, 4, 2, 5, 7. And G is 0, 2, 1, 0, 2, 4, minus 4, 2, 7, 0. Okay. Then the range of F composite G is, okay, F composite G. Here, by drawing the diagrams, we can go for F composite G and then we can take out its range. Okay. how what is that? What that comes is 0, 1, 2. Okay. After drawing the diagrams, you come to know it comes at 0, 1, 2, the fourth option. Next is let A equals to ABC and relation R equals to AA, BB, CC, BC on a set A, then R is, it is reflexive one, but that is not given in the options. See, options, it is a reflexive relation, AA, BB, CC is there, but options like that are, means options like reflexive is not there. Okay, so what type of relation it will be? Transitive relation. Is it the transitive one? No. A B B B C. BC is there. Symmetric. It's not symmetric also. Equivalence. What about equivalence? Equivalence relation means what? Yes, if the relation is possessing all the properties, that is reflexive, transitive, and symmetric, then that relation is known as equivalence relation. Okay. So our answer is D, none of these. Okay. Then the next question is relation R on a set A of all the books in a library of a college given by R equals to XY, such that X and Y have same number of pages. X and Y are books, okay? And the books are having same number of pages. So what type of relation will be? Yes. What type of relation that will be? Just don't tell me as transitive because it is given in the bold type. Okay. You have to give the answer for that. Yes. Think on this. You think on this. X and Y have same number of pages. If you have different answer, you can tell me. I don't want it like means it must be transitive because I have given the answer that transitive. It can be all of them. Okay. So you can go for the think on it. Okay. No, sir. Because I'm just discussing MCQs. Just 2 MCQs are here. Okay. Next question is, if S is relation from a non-empty set A to a non-empty set B, then what is the correct one? This is the correct one. S is a subset of A cross B, that we know from the definition of relation. Then the next question is, let A equal to 1, 2, 3 and consider relation R equal to 1, 1, 2, 2, 3, 3, 1, 2, 2, 3, 1, 3. Then R is reflexive but not symmetric. Okay, as this is 1, 1, 2, 2, 3, 3, reflexive, but it is not symmetric. Okay, 1, 2, 2, 3 and 1, 3, it is there, means it is a transitive, but reflexive and transitive, it is not the option. Reflexive and transitive, it is there, reflexive and transitive is there, but not, it is written like this. So this one is the correct option, reflexive but not symmetric. Okay, and the last question is, the relation R is defined on the set of natural numbers as AB equals AB as A equal to 2B. Then R inverse is given by, means what R is, that we have to first think, and then about R inverse we have to think. A equal to B, 2B is given there, means larger number will be here. I think I have mistaken here. What AB will be? A equal to 2B is given, means if B is 1, A is 2. Okay, means 2, 1, 4, 2, 6, 3, it is R. Okay, and R inverse will be 1, 2, 2, 4 and 3, 6, like this. B option is correct here. It's my mistake. We have asked for R inverse. Okay. Second option is correct one here. Getting? Okay. So we will stop here. We have discussed these many MCQs here. You go through all of these, and if you have any doubts, you can come to me to clear the doubts. Okay, I'm ending the meeting. You can join the other one.